Today we're going to be doing Unit 5, Learning Target 12. So we're going to be talking about applications of quadratics because word problems can be difficult. So we're going to kind of work through when to use what type. So let's go ahead and let's take a look at vertex questions to start off with. So when we're talking about vertex questions, we're looking for questions that are referencing finding a maximum or minimum. So those are really key words to look for, are maximum or minimum. If it asks for either one of those things, then you know you are looking for the vertex of the parabola. So let's kind of review how we went about calculating the vertex of a parabola. So we're talking about skateboarding, okay? It says the path that a skateboard rider follows during a jump is given by the quadratic y is equal to negative 0.5x squared plus 5x plus 8, where x is the horizontal distance, so how far they're going over, and y is the vertical distance, so how high they go up. So if you think about the skateboard, they're going to be kind of going like that. So we want to find the maximum height of the jumper, so how tall they're going to go. So the first thing we need to do that is calculate the x-coordinate of the vertex, which is opposite of b over 2a. Well, in this problem, my b is a positive 5, so I'm going to do negative 5 divided by negative 0.5, because that's my a. Well, what I end up getting is negative 5 divided by a negative 1. Well, when I divide two negatives, remember that it ends up being a positive, so that's going to be 5. Okay? So then what we want to do is we want to take that 5 and plug it in wherever we see an x. So we're going to plug that in. Okay, so then when we plug that in, we can type that exactly into our calculator. So negative 0.5 times 5 squared plus 5 times 5 plus 8. And when you do that, you end up getting 20.5. Now 20.5 is going to represent how high the skateboarder jumps. So that's the answer to our question. Now it tells us that y is going to be measured in feet. So that means that the skateboarder goes 20.5 feet. Let's take a look at another word problem. Okay, so for the next one, we're talking about a minimum cost. So we're talking about a car dealership. It's going to model its operating costs from car maintenance by the function y is equal to 0.25x squared minus 12x plus 200. So y is going to be the total cost in dollars, okay, and x is going to be the number of cars. So the number 2 is asking us to find the minimum cost and the number of cars that are worked on to yield the minimum cost. Okay, so first thing we have to actually calculate is how many cars we're going to work on to yield the minimum cost, because that's the x-coordinate of the vertex. So again, we're going to use x is equal to opposite of b over 2a. So now I'm going to go ahead and plug that in. So since my b is negative 12, I'm going to write positive 12 over 2 divided by a, which is 0.25. Again, you always want to multiply out that bottom first. So 2 times 0.25, which is 0.5. 12 divided by 0.5 is going to give you 24. So that means that you need to work on 24 cars to get your total minimum cost. Okay, so that's how many cars you want to work on, but we also want to figure out what the minimum cost is. And so to get that minimum cost, we need to calculate out the y-coordinate of the vertex. So I'm going to take my quadratic, and wherever I see an x, I'm going to put in 24. So I have 0.25 times 24 squared minus 12 times 24 plus 200. So then I can go ahead and type this directly into my calculator. Just as a reminder that if you're using a crappy calculator, remember that you need to put a time symbol whenever you write out a parenthesis. So when you go through and solve this, you end up getting 56. So the minimum cost is $56. So that's how much that we will have to pay per car that we work on. But in order to get that price, we have to work on exactly 24 cars. So let's go ahead and let's take a look at questions where you actually have to solve. Now, when I'm talking about solving, I'm talking about using the zero product property or the quadratic formula. Typically, when we solve quadratics and word problems, we usually end up using the quadratic formula. So when questions reference how long it's going to take for an object to hit a ground or to hit a certain height, you need to solve the equation and identify the logical solution. Remember, that's using the zero product property or the quadratic formula. Okay? And remember, can you have negative time No, you cannot. So if you end up getting negative time, then you know you need to cross off that negative time answer. Because as of yet, we haven't exactly figured out how to travel back in time. So let's go ahead and let's take a look at number 3. It says an object is being launched at 19.6 meters per second from a 70.8 meter tall platform. The equation for the object's height, s, at time t after the launch is s of t is equal to negative 4.9 t squared plus 19.6 t plus 70.8, and s is going to be in meters. Okay, so when does the object hit the ground? So in order to figure out when it hits the ground, we need to solve for t. And in order to solve for t, we need to use the quadratic formula. So when we're on the ground, we're 0 feet above the ground, if we're physically on the ground. So in order for us to solve this, what we're going to have to do is set this equation equal to 0. So we get 0 is equal to negative 4.9 t squared plus 19.6 t plus 70.8. So now I'm going to go ahead and use the quadratic formula. My A is negative 4.9, my B is 19.6, and my C is 70.8. So now I'm going to use that quadratic formula. So I get that x is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. So then I want to simplify what's underneath the radical first. So I have negative 19.6 plus or minus the square root, and I'm going to go through and I'm actually going to solve that out right there. So in my calculator, I'm going to do 19.6 squared minus 4 times negative 4.9 times 70.8. And when I do that, I get 1,771.84. And that's going to be divided by negative 9.8. Now here I want to do two versions, a plus version and a minus version. So in my calculator, I'm going to do negative 19.6 plus the square root of 1,771.84. And then I'm going to hit enter, and I'm going to divide it by negative 9.8. And when I do that, I end up getting negative 2.295. Now let's talk about rounding. Since the third number is 5 or greater, I need to round this guy up. Well, when I round 9 up, I actually end up having to round the 2 up. So I get negative 2.30. Now that's negative time. So I'm going to go ahead and throw that answer out because negative time doesn't make sense. Then I'm going to do negative 19.6 minus the square root of 1,771.84. And then I'm going to hit enter to get my solution. And I'm going to divide whatever I get as my answer by negative 9.8. Now, when I divide that out, I end up getting 4.906. Again, talking about rounding. That third, oops, not that. I'm looking at the wrong problem. When I calculate that out, I end up getting positive 5.493. Well, since this 3 is less than 5, I can just round it by cutting it off. So I end up getting 5.49. Now it talks about t being labeled in seconds. So that means that after about 5.5 seconds, our object is going to hit the ground. Last but not least, let's take a look at number 4. So for number 4, it says an object is launched directly upward at 64 feet per second for a platform 80 feet high. When will the object hit the ground? Now you'll notice that 64 and 80 are already included in the problem. So what we want to do now is we want to use this quadratic to figure out when it's going to hit the ground. So all that means is I have to take this quadratic and set it equal to 0. Because when it's equal to 0, we are exactly 0 feet above the ground. So then we're going to get t is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. So now I'm going to go ahead and simplify underneath the radical first. So I have 64 squared minus 4 times negative 16 times 80. Now when I simplify that out, I end up getting the square root of 9,216, and that's all going to be divided by negative 32. So now I can go ahead and I can calculate this out. So first thing I'm going to do is use a positive version. So negative 64 plus 9,200, the square root of 9,216. And then I'm going to hit enter, and I'm going to divide that by negative 32. And when I do that, I end up getting negative 1. Well, negative 1 doesn't make any sense. We can't have negative time. I'm not going to launch it backwards in time. That doesn't make sense. So I'm going to do negative 64 minus the square root of 9,216. Again, hit enter in your calculator. And once you do that, you're going to get divided by negative 32. And then you get 4.906. Now, if we want to round it to 2 decimal points, I need to take a look at that third decimal point. Since that third decimal point is 6, that's greater than 5, which means I need to round this 0 up to 1. So I end up getting 4.91. And again, our time label is seconds. So it takes almost 5 seconds for our object to come back to the ground. So that concludes your note video for today. Thank you for listening.